Okay, so you guys had a homework problem, if I remember right. I will go around and check your work.
No.
This is a graph. No, mine is just a graph that I don't feel like it's right.
All right. Just point to your work for me, and I'll see that you did it or not did it. So did you do it? I mean, you got a graph going, but did you do all parts or all parts of the question? That's what I'm going to ask. No, not really. Okay, gotcha. Bryce, did you do all parts? Yes or no? Did you complete the question? You would have had to work probably afterwards, right? I don't think
All
there
I
was.
asked is illustrate the implications of the regional economy.
Okay, yeah, I'll just put it up. Oh yeah. This is the question. This was your homework. Number 7. That was this one, right?
Number 6.
Number 6. Not even going to drop the screen yet, but I'll walk around the room. So what does it say? Illustrate the implications of the regional economy, including the values for the city population, the rural population, and the regional utility. So, fully answered question. In fact, I'm just going to go around the room and then I'll come and look, but let's just go with a yes or no. Carlos?
No.
No. Halen? Jacob? Julian? Gabe? Tyler? Not here. Absent. Jonathan? McKenna? Lawson? Not here. Oh, he's just joining online. Oops. James?
Yes.
Yes. Woo! Okay, so now what I'm going to do a little differently than in the past, all the yeses, I haven't got up, let me finish first. Zeke?
Yes.
Mando? Is not here. Aaron? Also not here. And Mackenzie? No. Bryce? Yes. Andrew?
No.
No. All right, so here's how it's going to work today. All the no's, your points are all going to accrue equally to the ones who did yeses. So apparently I need to bump up my incentive system. So you guys just got a lot of extra credit points because I want you all to come to work, come here prepared. I'm not being kind of like, oh, this is your homework, do it if you like, or do it if you don't. I expect you all to do it. And so you're
Yes, I did the homework.
point to become. So Lawson, yeah, you just jumped on. Did you do it? Did you complete the, basically complete the problem? Yep, he's holding it up. So Lawson's a yes. And then who just came in late? Tyler, did you do this problem in its entirety? Basically, illustrate the implications on the regional economy, including values for the city population, rural population, regional. Okay. Anybody else that came in late that I didn't get? Okay. All right, so yes, I do really want you to have that as homework. I don't think it took you very long if you would have just spent a little bit more time working on it, right? I don't know, you guys tell me, the ones who completed it. Did you struggle with it or did you get it though? See, I want to reward you. So all you guys are going to get the no's, are going to get those points equally distributed. All right, so now back to the problem. What did you get? Those of you who are yeses, do you want to come up? Zeke, why don't you come up?
Sure, it's really bad graph.
That's okay. We'll work with it. I should probably drop the screen. It's not easy to see. It won't be so sticky.
It's not this one. It's up to the side.
Okay.
This is all right.
All right, explain yourself here.
Okay, so I mean, it's just figuring out the utils with the new. So this is the old urban like line. It had 16. It was at 54. So
Yeah, I'll kind of walk through, you tell me what you did here. So there's 24 million divided equally between the city and the rural. So it's equal distribution at first. So we had a 12 and 12, is that right?
yeah.
Okay, and then the initial common utility is at 50.
So,
The urban utility curve peaks at 8. So that's the first piece. The urban one peaks at 8. So you have it peaking at 8?
Yeah.
Okay. And then we have this slope between 8 and 12. Tell me how you did that between 8 and 12. It was a slope of -2.
we're at between.
Between 8 and 12, basically how you built your thing there. Yeah, so it goes to 9.
So
And then,
this is when they were both equal to 12. So like when they were both at 12, it was at 50.
well, start at your peak of 8.
Okay.
And then the slope is 2, -2. So talk to me about this point you did here from going from 8 to 9.
Okay, so. Well, it said it went down by 2, so it
Yeah.
went from 86 or 58 to 86 or 58 to 56.
And that's just using the slope,
So,
right?
yeah.
That's the first part of figuring out all these numbers, is that that's going to go down by 2 each time. So then 10, you could have had maybe a 10 in here. From 10, it would be down from 56 to 54, right? And then from 54 down to 52 would be at 11. And you just kind of chunk your way down. That's all it is. So setting up the initial utility curve, that would be the way to approach that one. And then it says that the rural utility curve reflects mild increasing returns. In a population range of 12 to 16, the slope is 1 util per million. So where's your 1 per? Did you do that one?
Is that a really different graph then?
That's what I'm wondering. Did anybody do that a little differently? Let me let you explain your answer first, and then we'll kind of press that. So,
Okay, so this is what it would like the old before, it said the upgrades. So this
Okay.
is this top line is the after the upgrades. So
now explain yourself there though. What's the 16? Why do you have it
This?
peaking at 16? Yeah.
so that's when it was at when it was at its highest to 16. What's it called?
The peak or the
Yeah,
maximum.
okay. So it was at 16.
But where did you get that?
That's what it thought it was.
Okay, it's not in the problem now.
Okay, it said it went from 8 to or 12 to 16.
Okay, yeah, it says in the
So,
population range from 12 to 16, it's a slope of 1, but you have it maxed at this. So what I'm reading that is that at a slope of 12, starting at 12, we have it going at a 1 minus 1. See, it's the same thing you did here. At the maximum of 8, we have it at the 12. So that's what this is showing, the maximum utility at 16. It seems like you're reading more into the problem there on that part. And that's okay. I probably should have kept my mouth shut. I want you to keep going. So what's your end answers? So you have to shift up is where you were at.
So yeah, it doesn't look like it was supposed to be at 54.
Okay.
At 16 and it went to 57.
Okay.
And I was just it might be wrong.
And you have it going up by 3, correct or
Yeah,
not?
3 from 54 to 57. It looks like it's at 56.
Oh, I see. You were at the 54 to 57.
Yeah, I just threw the line.
Okay. So conceptually, I mean, this is the right idea, that it's shifting up by 3. But yeah, kind of an ugly, shaky graph, but you still got the extra credit, so good job. Good job attempting it. Who else was a yes? I'd like to see your work. Come on up, Jameson. And who was my other guesses? We had Lawson and Bryce. Okay. Okay. All right. We'll come. nice to talk to you.
You have the question.
Yeah,
Okay.
and if you want, you can put the question on the overhead so that other people can see what you're asking.
So I kind of went back into the chapter. I kind of looked at like figure like 7.5.
Okay,
I kind of did that. So I did like 50 right there.
oh, got a little blurry on us. Might try to hold it up a little higher. Let it focus in and then bring it down. See if that and go down slowly. One of these is the autofocus. I guess we'll figure it out together. Here it is. Did it focus in? Okay. I think this one's the focus right there. All right, go ahead. You're good.
And so I kind of looked in like that little section, and I kind of worked out like how they did it in that little section.
Okay.
It said that the workforce was 24 million.
Yeah.
So I kind of did some math and I added some stuff. So I got the popular workers like 4 million, 8 million, and 12 million.
Okay. You got it in 3 cities.
Yeah. And so I just like started like working out that way.
Okay. So kind of similar to Zeke, you're kind of reading more into the equation, into the problem, but you got it peak. This one right here looks like I would like to see a little more information on kind of what this peak is, and then if it's going, what is this one? Is that a 1 or is that just a dash line?
That was just going to like 12.
To the 50. Okay. All right, grab a seat. So it was just Bryce and Lawson left. Bryce, sounded like you were, I'm not sure if you have something to contribute or not, but go ahead.
I know it makes sense, but it's not what the question is.
Okay,
Because I set my graph wrong.
a little higher. Okay,
So I had them both at like 50 to start with, and then when the one raised to 53, I knew the 8 million had a -2 slope, and the other one had a -1 slope.
yeah,
So I thought that the 53 would increase by 1, bringing it to 52, and the other one would increase by 2 because it had the -2 slope. So I thought it finished at 7, 17, 52.
okay.
But I'm not.
Yeah,
that's
so
what it was
I'm
actually
starting to see a
asking.
theme of how we can clean things up. So, okay, grab a seat. We'll definitely work on this together. Lawson, I don't know how this will work here. I was gonna turn the screen around, but then I realized that's not gonna be very easy with the way we've got it. Actually, if you're talking, maybe we can. Let's try it. Let's have fun. So you unmute yourself and
Yeah.
I can pin you. Hold on, I'm gonna pin your screen. There we go. And then I'm gonna spin you around to the class. Ow. Maybe. All right, there's Lawson. Now hold your paper up like you were doing before. Let's see if we can see it decent or not. It's not too bad. What's your maximum point there?
53.
At 8 and it's 53?
Oh no, that's a 50 right there. And then I said that this curve went down while the other one went up, and that was the urban curve went down.
Okay, so you've got another curve off to the right. Okay.
Yeah, and then down low, I kind of did some averages from both cities. I said the big city would be 14 million because it was between 12 and 16, and that the average of the other city would be 10. And I used that to find what they might be afterwards.
Okay. Well, I like that you had a little more meat on the sides there. That's where we're going to all start together with this. Looks like we need got a little bit of work ahead of us here. So, let's see. I should keep it on that screen or not? Oh, did I forget to bring my other book? Shucks. I left it in the office. Well, let's just go to the board. This is my new thing. This is my new whiteboard so that I don't always have to jump up. Got something highlighted here. Okay. So I want y'all, I'm going to go walk around the room and look. This time I want you guys to be a little more careful with your graph and drawing. So this time, everybody start, everybody in the room kind of start from scratch, because everybody needs a little bit of work in different ways here. And I think with our scaling, we know from the problem that in the initial equilibrium, a region's workforce of 24 million is divided equally between city and rural. Okay, so there's 12 million in each. Yes? All right. The initial common utility level is 50. So currently they're operating at 50 between the rural and the urban. The urban utility curve peaks at 8 million. And in the range, in the population range 8 to 12, the slope is 2. We're going to start the problem there. So if you want, go one, nice even spaces this time. We're not going to be sloppy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we can go 13, 14, 15, 16, 17, 18. I don't know if I want to go out to 20, but we're going to go to 20. So 1, 2, 3, 4, 5, 6, 7, 8, 12, 14, 15, 16, 17, 18. Messed up. Let's say double one of my numbers here. I'll stop at 19. You can go to 20 if you want. And then on the horizontal axis, or the vertical axis rather, I think we can just probably start this thing off at, oh, I don't know. Let's do about 40. And then we'll do 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 50. 1, 2, 53. So this obviously the scaling is a little tickly there. And so this is utility, and this is workers. And so now draw out the urban utility curve following those rules. I'm going to walk around the room. Draw the urban utility curve. Start with the peak. I guess I'll help you out with the peak. So here's the 8. And we have a peak. The urban utility curve peaks at 8 million people. So there's the peak. And then the urban utility curve between 8 and 12 has the slope of 2. And we know that each population, the urban and rural, has how many people? 12. So make sure you have this shaped appropriately with the right number over here so that this point comes with something. That's going to be the key. I'll walk around the room. If you need some help as you do it, I'll look at where you're at and I'll give you a nudge. But I want you all to think through that part. That's how we set this one up. So go to You got this point, right?
Yeah.
And now that's basically one of the ones you drew before, but now we know between, go ahead and put an 8 there. We know between 8 and then let's find your 12, I guess. We know between here and here, the rise of the run is -2. So down 2 over 1. So when we go to 9, draw that point. Go to 10, draw that point. You can draw every point, or you can, it's not going to be a curve, by the way, because we're just assuming a straight line, right? It's the slope is -2. It's going to end up looking like just basically a straight line, and that's okay. I wanted you to be exact in here, so you should have little slashes, just like a, yeah, that's 10. Looks like you're pretty close. So. Basically, at 9, what's the utility level at 9? What is it? Tell me the number. You started at 50 and 8, and we know the slope is 2, 48. So now go to 48, dash, 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 999, and that's exactly where it should go. At least maybe one in the middle so that I know what you're talking about, like especially this one, let's have that at 50. But this scale should perfectly match up with, that's why I wanted you to put exact scales down. I want you to get that right on the money. Okay, good. Got the 9 down, so that's 48. Give me a couple numbers on that scale so that I know you've got the slope down. Look at that. So 8, so 9 was what? I want that number. Yep. So make sure you put dash, dash, dash 48. We're going to be a lot more tight with this problem so that you guys see it. Hopefully, you can take shortcuts later once you really understand it. So I'll make sure you got it here. So yeah, give me like one of these numbers at least over here. I want to see that number on the scale. Yeah, it's a line. I mean, you can connect the dots if you want to. It should be a perfectly straight line. Lawson, let me see your paper. You can hold it up. Okay, yeah, that looks good. All right, so basically we go down to, I did these all in equal, so at 48, dash, 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 99999, and 46, dash, 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 and 10, 10, 10, 10, and 11, so that's at 44, dash, 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 up, 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 up. And then finally at 42, we're at 12. Okay, now what's really going on here is it's, it would be a curve, but this is just an assumption here that that's what our utility curve looks like in between those spots. All right, so any questions on that? Everybody's cool? It looked like everybody had it, but. All right, now what does it say? The rural utility curve reflects mildly increasing returns to scale. In the population range of 12 to 16, the slope is 1 util per million. Suppose that the nation invests. So first of all, the initial common utility is at 50, and it peaks at 8 million people. And in the population of 12, the utility curve is that. The rural utility curve reflects mildly increasing returns with 1. All right, so in 12 to 16 range, where does that one go? So where's our peak with it? So we kind of want to think about the current level of where the city's at. So if we're at 12, is that the peak with 50? So in the initial equilibrium, workforce is equally divided. And it's in equilibrium, would we be at the down, on the down slope or the up slope of the curve in general?
You have to be on the down.
To be on the down, right? So that's what we had was with each one, it would be somewhere on the down. And so we got to keep 50. The urban utility curve peaks at 8, and the population 8 to 12. It's going by 12. So at 8, is it peaked from that information? So we got between 8 and 12. There's a slope. So the initial common utility level is 50. The urban utility curve peaks at 8. And the population range of 8 to 12, it's this. So could this set of lines be here? Between 8 and 12, we got a slope. So is it possible that these lines continue up here and the peak is up here?
Yeah.
Why is that?
For the new one?
For the existing. No, I'm talking about, I'm back to the urban one here.
Oh, the peak.
So the peak, the initial common utility is at 50. And the peak, the urban utility curve peaks at 8. So we know it peaks at 8, and then between 8 and 12, it looks like that. So that is the top.
That means that if the initial common utilities would be wouldn't the 50 be at the 12 then? If 12, if that's the initial common.
That's what I'm trying to wonder. Is that where the,
Where the 50.
that's where the 50 should be? So should it be here? Or should it be, here's the 50,
Your peak's still at 8, your 12 just needs, the whole thing just needs to shift up.
so shift up.
Yeah, to where 12 is now at 50. And then that's gonna-
Like this.
And yeah, and then the 8's gonna be the 8. Oh, yes.
Does that make sense?
That's good.
So let's read it again. In the initial equilibrium, a region's workforce is 24, so we know there's 12, and 50 is the equilibrium. The urban utility curve peaks at 8, and then between 8 and 12, it's the slope of 2. So are we breaking that rule by moving this up to here? So let me just put it in orange. So basically what we're suggesting is, have we violated the problem by doing this? And by the way, what would be this number here? So we've moved 4, and the slope is 2, so it'd be 8. So what is this utility number? 58. Does that violate anything with the problem? No. And it actually makes more sense because equilibrium is on the downward slope of it, right? It just happened to peak at 8. All right, so any questions on that? So now, well, you can keep what, well, it might be ugly. I would keep what you got. If you use pencil, I always use pencil when I was in your guys' shoes. So pencil, and I always had a big eraser. So the orange line is what this problem is addressing. Does everybody see why? Okay. So redraw the orange line with 58. So now, from the problem, what do we know about the rural? The rural population has mildly increasing returns. In the population range 12 to 16, the slope is 1. Suppose the nation invests, and now we get into the other parts, but let's tackle this part of it. So we know that they have a population of 12, and what else do we know? -1 is the slope. What else do we know about its utility level at 12?
Yeah, is it carbon?
Put it on the positive. On the, up here, the slope is 1 util per million instead of -2. So we have a positively slope on the rural. Okay. So we got 1 util per million, we've got the 12, and so back to, we're at 12, what's our current utility level? 50. We know it's 50 because we were in equilibrium originally. So that gives us our starting place for the rural. Yeah.
How can it be a positive slope if it's only?
Well, yeah, that's a good. The start of this being at 50, we're showing the dynamic process. You're right. The starting place is at 50. That each are, nobody has incentive to move from 50. You're both equal. So would I want to move to the other city? It's at 50. I'm at 50. No. But is it stable? So what we talked about with the dynamic part, is it a stable equilibrium? And so let's just talk about that here. If we're on the positive slope of the rural one, and we're at a level of 50, this is basically what our picture is going to start to look like. We're at 12 million. Would I want to go to the big city who's also at 50 on the urban? So I go down, I come to this community, it goes to 49. Now what happens here though?
Yes, because it's got a lower population.
Because they're leaving. Yeah. So this goes down.
So, but it'd be the other way around, that people would want to move.
Okay, but now we get to the slope. What's this number? That's basically what this is teasing out. So we lose 1 to 11, well, which is our 1, let's say. It drops down to 49. And so here we add 1 and we drop to 48. And so what do? Go back. Yeah. So with the slope, so when the author brought us through that, it said they may be too large, but not too small. And so here, with the slope differential, it would be pushing you the other way.
Yeah, but wouldn't people from the urban area just move to the area, because then both of the, but then it's gonna go to.
Okay, so going this way. So
Yeah,
we
because then it's gonna go 52 and 51.
so we leave here, we go to 52, and I come here and I only get 51. Was that a good move?
Yes, because you were at 50.
You were at 50, that's true, yeah. So you gain, but now would you want to go back? Yeah. Well, you've got the 52 that's attracting you. They're at 52 units of happiness.
But it's gonna go back to.
Yeah, but you're chasing that. Would you want to make that move? That's the argument. The dynamic story, by the way, is a little not perfect with kind of telling them. But you're right. If I move now back to the city not knowing, but they're at 52, so the carrot is there. So then I go to the 52 and we get back to the equilibrium. So
You want to move back in because.
right, exactly. That's what I mean. So it's kind of maybe this little wiggle, like I'm conflicted. I want to go back and forth or something. Again, this isn't that part of the story is a little far-fetched, but it is a way that you could be sticky, but that's not the general story that we have. But under these circumstances with different utility levels, another way to look at it is if this one was at 50, but the big city was at 38, or something, you definitely won't want to leave, right? So, all right, let's try to see where this thing brings us then. So now we're at the 12, and we have this positive slope. of 1. So we go up 1 to 13, and we get 1 at 51. So it would look something like that.
Does it peak at 16?
No, it's gonna peak somewhere over here because of the positive slope. Yeah, but we're not told where.
We just know it's positive 1, 2, 6.
Between 12, 16, yeah, we know that part. So I went a little too far. 12, 16. So that part of it's 1. And we know that we're starting here is what they're just telling us that that's the 50. That's our starting place. Okay, now the nation invests in rural structure, which shifts it up 3. So the rural utility curve shifts up 3. And so now we jump up to 53. And it's a vertical shift up. And now we kind of let the chips start to fall. What's going to happen? Rural's at 53, and these guys are still at 50. So we're at point A. We're at point A. Oops, that's point A. We're at point. Oh, I'm on my green one. Sorry. All right, we're on my green one here. So at which is the orange, not green. So here's point A for the orange team. And this was point A. Let's call it A prime, since you guys don't have colors. A prime for the red team. And now we're up to the green. A double prime, or B. Why is green? I just chose it to be green. No, why. This is the upward, the shift up. So boom, that's our shock to the system. There's an innovation. The utility curve shifts up. And now what's going to happen? Who goes where? City people need to go to the rural area. Okay, so now we can kind of just do the lump chunk here, which means if I lose 1 to 11, what happens to my city dwellers utility? Goes up to what? 52. So if we go up from 11, that was this part, and it would be at 52. And then when we added somebody to the rural area, it goes to 54. So now the 13 is at the 54. And then what's going to happen? Going to go one more. So now we go one more, and we lose another urban dweller, and we go from 11 down to 10, bringing us up to, what is it? 56. We were at 52. 54. Yeah, so we're at 54. But did the rural stay at 54? No, it went up to 55. So now we're at 55. And then what happens? One more. So now we go up to, or the urban dwellers leave again, and we're down to 9 now. So let them keep track of. Hopefully correct.
56.
And we go to 56. And then the rural dwellers, they go up to 15. And they're at 50. What were we at before?
No, 56 is fair 50.
We started at 50, so if we ever get lost, we can go 1, 2, 3. We're over 3, and it was a 3 to 3, so we're up to 56. And then what? We're done.
Why would you?
Each are at 56.
Okay, but if another one goes, it tells you that you got the positive one up to 16, so if another one moves, it then moves to 58 and 57.
We're back to kind of what you were arguing here, which is correct. So we leave And this one goes up, but this one doesn't go up by that much, so you'd like to come back. Right? Because of the slope difference. All right, so the main part of this exercise is to get you thinking about the movements and the slopes, and they could look different and different places to just kind of understand the dynamics of some of the things. All right, so back to answering the question then. The city populations. So city. Let's start with the city of the rural population equals at the end conclusion. Did we go 1, 2, 3? Did we go to 16?
No. So
15. And the urban, rural, or the urban population, I guess I didn't have to say the city urban is what I meant to say. City, the urban population, I didn't have to write it this way. Where did we end up in the urban area? 1, 9, right? We went 3 spots over. So they're at 9 million. They're at 15. So we got the city population, which is the urban, the rural population, and then the regional utility. 56. Utility of the region equals 56. Whew. Okay, clarifications. It's pretty good discussion working through. That's a hairy problem. Jason?
Can you just go over the last part of the green?
So basically, each time we add a person to the rural area, we're climbing by 1 is the way the function is. So 1 person comes and it goes up from 53 to 54. 1 person comes from 54 to 55. So it's always increasing by 1 as we go up. Over here in the rural, because it was a slope of 2, we're climbing 2 each time. So that 1 person who left caused us to go from 50 to 52, 52 to 54, 54 to 56.
Okay.
And then that's where equilibrium is at 56.
Okay.
Okay, anything else? So it gets kind of ugly with these lines, but of course you could have, something of a, you guys don't need to do this, but we know we peaked at 8 here, so that might have looked something like this, and maybe this guy, looks something like this. We don't know where it peaked, but we really, to answer this problem, we didn't have the rural peaks at 19 or something. We didn't know where it peaked. So that would be kind of putting more into the problem than what we. Yeah.
Does where they intersect now, is that like a 10 or 11? Does that mean anything?
No.
Okay, I
No.
don't- that is-
I guess the only thing it would mean is that if the population was split and it happened to be this, then that would be a level of some sort. But yeah, there's nothing special going on with it. All right. Woo! Well, that was fun. Okay. So let's jump in to chapter 8. Now, we're done with chapter 7. We finished all the stuff yesterday. This was the final problem. So Sunday night, you guys had those problems, and we're going to get into chapter 8. We'll wrap up chapter 8 Monday, and then your problems for chapter 8 will be due Wednesday night, because then Thursday we'll go over the problems and review everything for the test, which will be on Friday. So a week from today, chapters 1 through 8 is the test. And by the way, chapter 9 is included in that week's material, but that is kind of a reading comprehension, and there's no back of the chapter problems or anything. And we're just gonna do like some discussion posts for that after the test. So that'll follow up on for Sunday. Okay. Okay, so now we're gonna do a little more supply and demand. Jonathan was asking about the golf club because we're gonna do a little supply demand stuff here. So urban labor supply and demand. Similar to what we've been building on. So the metro area is part of a larger regional area in which households and firms are perfectly mobile between cities in the region. That's an assumption. So they can move between those two. And the demand for labor comes from the firms in the city, while the labor supply comes from the households living in the city. So we've got kind of this urban rural concept, but here we're focusing in on the urban part. All right, elasticity demand. What was that formula? Who's got that off the top of their head? Elasticity demand is change in quantity over change in price. Is that it? Everybody's good? I hope not.
No,
Jacob, what is it?
percent change,
What's that, Lawson?
percent change.
Percent change, not the change. This is a slope. You said percent change, Collins? Okay. So percent change. All right, so we're dealing with the percentages. And we have elasticities for lots of different things. We're especially going to see in this chapter, but you can do an elasticity for anything. So we did the income elasticity in principles class 2. So if I change, my income goes up by 10%, how much more beer do I buy? Right? The percentage change in quantity from your income changing. That's the income elasticity. And then you can do the elasticity of some variable X with respect to some other variable Y. And that can be anything. I mean, is it possible to compute the percentage change in COVID cases? Is it possible to compute the elasticity of COVID cases with respect to beer consumption? Yes, it's possible, right? So I brought up that maybe, you can almost like, maybe beer helps COVID, right? It seems like, or maybe beer causes COVID because people have increased their beer consumption during lockdown, and then COVID cases have gone up. So maybe there's a relationship there. So we can do that with any two variables is the main thing here. So we can compute elasticities. Economic theory helps direct us on the relevant variables we should be using, whether that makes sense, like COVID and beer, probably unrelated with each other. So they're kind of dumb to be testing it, even going down that path. So we use economic theory to think, well, there's probably not anything there. There might be a correlation, but not causation. Okay, so evidence of localization. Kind of localization economies, productivity, and births. What's that? Births of what? Firms. So we're going to talk firm births. And what's productivity again?
Oh, the increase in outputs.
Okay, increasing outputs while inputs remain the same. That works as far as a way of describing it, but it doesn't have to work that way, I guess is one way to think on it. Okay, so what's the formula? Jameson? Good. So output or number of units of output. So for our productivity, how productive is our resource? The number of units of output divided by the number of units of input. And it's important to have it this way because it doesn't have to work the way Bryce described it. I think Carlos did that way before. It describes productivity okay, but doesn't complete the picture. So what Bryce had said was increasing the number of outputs while holding constant the number of inputs. Is that a fair characterization of what you said? And that describes productivity, but you can also be more productive by holding constant the amount of output and decreasing the amount of input. right? So the formula really captures all the ways to make, how do you make this thing go up? Well, this goes up and this stays the same. This goes up and this goes up, but this one goes up faster than this one goes up. I fooled you on that one, right? So this goes up by 10, and this goes up by 2. If it goes up, but this one goes up faster than this one goes up, that's an increase in productivity also, right? So there's lots of different ways to make the math work out so that this expression, this ratio, you got to make it go up. That could be this stays the same, this goes down, this stays the same, this goes up, and this goes up by less. This goes down, but this one goes down by even more. So this one goes down by this much, this one goes down by this much. That's an increase in productivity too, right? So you kind of gotta think about it that way to really capture all the ways that productivity could change. Okay. So wow, look at these here. We've got elasticities all over the place. So the first one here, does localization economies give us higher labor productivity? So output per worker versus industry output. So the idea with Henderson's study there, thinking about agglomeration, is that the industry's output goes up. Does an individual worker working for some company, does that person's output per worker go up? That would be kind of a clever way to capture at least this idea of agglomeration, right? So as companies cluster together, was there some spillover effects in terms of productivity? That would be one way to capture it. So we've got 0.02 to 0.11, and then another study did 0.27. How about firm births? So industry output goes up. And we're back to here with any old elasticity, but now we're going to be measuring industry output here goes up. And does that cause new firms to be born, right? Does it attract new? So this industry, imagine this industry is growing, and it's like maybe there's a cluster forming, right? There's something good going on. This industry is growing, and then it attracts new firms to this cluster. So it might be another way to try to measure that concept. All right. Second part of elasticities, interpreting them. Who can interpret 0.11? 0.11. No, that's not the direction we're trying to take this. So interpret. So you come in, you're the new hotshot econ major at your company. And you tell your CEO, who's got his MBA, very reputable, very sharp person with financials, and you're like, boss, I got a 0.11. What does he tell you? What does he tell you when you say, boss, I got a 0.11 for elasticity? Lawson, looks like you're trying to speak. You're unmuted though.
Every 1% increase in quantity has a 0.11% increase in price.
Okay, good. Did you look back at your old notes for that, or did you pull that right off the top of the document?
Yeah, I just remembered.
Impressive. So back to what the boss says though. Boss, I got elasticity of 0.11. He says, what does that mean, right? That's not normal in MBA, finance, lingo, accounting. If you take Professor Wagner's class, I don't think she has anything on elasticities. This is kind of unique to economics. And it's an important concept, but you got to be able to explain it to somebody, whether that, and that might very well might be your boss. All right, so Lawson, you have the right idea there. You said it right as near as I could hear. So we know that the elasticity looks like this. So we've got a different elasticity here of output per worker to industry output. And so one of the things that's not obvious that I wouldn't expect you guys to know right off the top here is that elasticity, when we calculate it, the first argument And the last argument, this is the one on top, which isn't too bad because it's the comma, but in terms of the division business, so we've got output per worker, percentage change in output per worker over the percentage change in industry output. Industry output. So first argument goes up top, second argument goes on the bottom. And now, Lawson said, you used a 1%, right, Lawson? Okay, so he remembers from principal's class and maybe some other classes, since he's had quite a few with me already. What can you do with any number to turn it into a fraction? Divided by 1. So that's what we're going to do. That's kind of the trick to do here, is to take 0.11 divided by 1 is still 0.11, right? But now what's cool is we can connect the picture here and say a 1% change in industry output leads to a 0.11% change in output per worker. All right, so let's write that out. I'll come over to this side of the board since I don't want to erase the screen right now. So here's the interpretation. A 1% increase in output per industry output in industry output leads to a 0.11%, and then it's a positive number rather than a negative number, so it leads to an increase, right? It's a positive relationship, leads to a 0.11% increase in output per worker. All right, and there you go. Now you got something to tell your boss. Because the boss does understand that. It's like, boss, hey, if the industry output grew by 1%, then we saw a 0.11% increase in output per worker in productivity. Okay, questions on that? Now the book does the interpretation with the 10%. Either way is fine. It's no big deal. That's why I wanted to. Lawson went with the 1%. But sometimes, especially at the around the executive table, when you're talking to your boss, they might think more of, well, 1% is kind of little. Maybe a 10% is more appropriate. So a 10% increase. Now we're just putting a 10 down here, and we're just going to shift the decimal place over, right? So this could easily become 10 and 1.1. So maybe I'll leave this. You guys could actually do this on your thing. Let's do it this way. Put the 1, and then we could put, which is equivalent to 1.1 over 10. And now we're following a 10% increase in industry output leads to a 1.1% increase in output per worker. All right, questions on that at all? All right, so yes, you're going to see some elasticities. Let's see how good you're doing. Everybody, write this down on their paper. Interpret that. See how well you did it. We've got the elasticity of firm births, if you want to use the word firm, but you can just put births. But that's the firm births versus industry output. I'm going to randomly select one of your papers to read out loud exactly what you have written on the ground, or what you have written down. And all I'm asking for is the interpretation. So interpret 0.43 from Carlton's study. I'll give you 30 seconds. 5 seconds. Ready to run from number generator ready today or not? Jonathan, number 3 and 17.
60.
16. You made it tough on me, didn't you? All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hey, let me see your paper. All right. Gabe's our lucky winner. Oh. So you just did the fraction thing. Okay. Percent form a number of bursts, 0.43. You're fired. Z, you're next in line. And that's your future boss, but I know you can do better. A 10% increase in firm bursts, 10 leads to a 4.3% increase in industry output. You get promoted.
Yes.
Okay. So, Gabe, you cool with that? So you were there. I don't know if you just ran out of time, but you really didn't need to do this part. When I ask for the interpretation, I'm only looking for this. So you can, and it's fine to either put it in 1% terms or 10% terms. So what you put down on the fraction was fine, but I want you to put that in words. So I encourage you right now to put it in words. So you have it in your notes. Good. That was the interpretation. Mackenzie.
You like explain that, like how, you know, like with the 10% increase in.
So you kind of need to memorize this thing, but how I'm putting it into words is way here. Actually, Gabe, let me have your paper the way it was. I know you. I bet there might be a lot of you that did it. So how to do it is to, and it was okay to start off this way, but let me put it to you this way. Did this help your boss out that much more to verbalize it to him? No, right? So from this stage now, you've got firm bursts and you've got industry output. And so now we come back and use this language. A 1%, I'm going to use both of yours, Gabe, here. A 1% is down here, so the 1 goes with the denominator. The 0.43 goes with the numerator. And then it just kind of reads itself, right? A 1% change in industry output leads to a 0.43% change in firm bursts. And then you're done. And if you did the 10% method, like Gabe had converted it here, you could also say a 10% increase in industrial output leads to a 4.3% change in firm bursts. You're just, yeah, you're just putting into words what the equation says.
Okay.
John,
Could you read it the other way? So it's like for a 4.3% change in firm burst, industry output increases 10%?
no, and that's a good question. The reason we have a little bit of theory underlying this of we're pointing to a potential causal chain that this causes this. And that's why. Now, in reality, we might not really know that causality, but that's what we're attempting to say. We're saying this is the independent variable, this is the dependent variable, right? So think about it from good old price elasticity. The price is what consumers make their decision on how much to buy. So independent variable, dependent variable. Good question. Because it could go the other way. You're right. You could kind of work it the other way, but that's what we're trying to do. We're thinking there's potentially some causality, and it's really the external independent variables. You might remember from those of you who are in entrepreneurial, the exogenous versus endogenous. So the outside factors are the downstairs. That's the exogenous factor. And then we have the determining factor, the endogenous variable, number of numbers. Okay, anything else? Now I didn't have Gabe, but be able to write down this interpretation. That's good. All right. Okay, so there's that one using the 10%. This did. So the supply curve. upward sloping supply. What are the assumptions in having it have an upward slope? We can think of, well, why doesn't it have a downward slope? You know, or why isn't it flat? So why is it upward sloping? And let's try to put it in this context. It's the supply of urban labor. The law of supply tells us that, let one of you tell me, what is the law of supply? And you can think of it in this context, or I don't even care if you think of it generically. What's the law of supply? Let's see, we gotta go to the random number generator for this one. You pick 16. All right, number between 3 and 8. Because I don't want to work that hard. 3. Where do we leave off? Zeke. 1, 2, 3. Carlos. What is the law of supply? Yeah, law of supply. You can think of a supply of beer, right? So if we, as I said, you can think about it anyway. So the law of supply, we got the price of beer and we got the quantity of beer. And with the supply curve, we usually have something upward sloping. What is the law of supply? No, no demand curve. Oh, this is the behavior of producers. So we don't have the supply, we don't have any demand curve yet. What does the supply curve tell us?
The cost of producing one beer, like the cost of one with respect to the price.
It is true that the supply curve is the marginal cost curve, right? Is one of our things here. But let's kind of use the supply language. Talk to me about moving from A to B. What's happening here?
Like the supply with the price.
Now we're back to what's the endogenous variable and exogenous variable? What's the independent and dependent variable? So let's start with price. As the price of a good goes up, the quantity supplied goes up, right? So we go this way. So price P1 to P2, Q1 to Q2. The law of supply says as the price of a good rises, which is externally given us to us by the market, right? We're not talking about a firm that's setting their price, but we're thinking more about a competitive market where really the consumer, they're either going to buy it or they're not. And so in a competitive market, if they're able to get more for their beer, do they want to put more on the shelves or less? They want to put more, right? Because the price is higher. So all of that holds constant everything else in the world. So ceteris paribus, we're holding fixed the rental rate of machines, the price of labor, the wages that I have to pay my workers. All of that stuff is held constant. So that's the ceteris paribus. So law of supply, an increase in price causes an increase in the quantity supplied, holding all of the things constant. That's the law of supply. Now, back to here. What is this thing saying? To interpret it in terms of a labor market, what's going on here? Okay, so an increase in workers, in order to maybe attract more workers, to increase the supply of workers. By the way, the supply, is that coming to us from the business or the households in terms of the grand scheme of the marketplace? It's one thing that's a little different. Like here, I'm talking beer, and this was Budweiser, right? But here, it's the household, right? Carlos just said it. It's the household, remember. So it's saying in order for me to attract more people to come to my business, or in this case, to work in the city, I have to offer a higher wage, right? In order to attract more workers to the city, there has to be a higher wage. Why? What's true about the city versus the rural area? More people, more congestion.
Higher prices.
Congestion hurts me, and so that I might need to have a higher wage for that. Lawson? Oh, you just muted again or something.
higher prices.
Higher prices, yeah, so in the city, it might be a little bit more expensive. What else is higher in the city? The like I was thinking the living expenses, right? So the housing, the apartment rents, that's a little higher. So that's what's kind of going on with the urban supply curve of why it would be upward sloped. All right, so these are the things that would give us the position of the supply curve. So what are some amenities? What would you mean by amenities of the city? Think about maybe the city you're from, what it lacks or what it has. Public transportation could be one, yeah. So that would be good if there's a bus system or some other train, subway, whatever. Parks, good. Pools, trails, fishing stuff, all of that public goods, right? So how about the condition of the roads? You know, so we talk about trails and stuff, but even what like the roads you drive on, some cities might not keep up with that as much. So disamenities, pollution, high traffic, so congestion with traffic, with people, pollution, smog, Jameson, cost of living. Cost of living is going to kind of play in. I want to think of something like specific to the city. That would be a little more tangible, but smog isn't necessarily tangible, but something like that. Taxes. What would cause you to think differently about this city in regard to taxes? Higher taxes would be good or bad? This is the taxes you're paying as a resident.
Mostly bad unless they make up for it.
Okay, that's the make up for it in what ways, Jonathan?
Really good parks and stuff like that.
Absolutely. So that's the correct answer. So again, back to econ class. Ceteris paribus, you raise the taxes, but don't increase the amenities. That's bad. Right? If you just increase my taxes, that's bad. But if you increase my taxes and increase my amenities, that'd be a different story. So number 4 on that list was residential public services. So an increase in residential public services, nicer parks, blah, 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 nicer roads, trails, blah, blah, blah. Good or bad? Good. Ceteris paribus, taxes are not high. Right, so all we're trying to do is kind of piece this apart, like holding constant the number of public services. If you just raise my taxes, that would be bad. If you lower my taxes, that'd be good. Holding constant the amount of public services. Now, when we come down here, holding my taxes constant, if you increase the public services without increasing my taxes, that's good. If you decrease my public services, that would be bad. Holding constant the fact that you didn't decrease my taxes too, right? So those 4 things are things that are going to move that thing around. And then finally, this is just the slope. Why is it downward sloping? So we got 2 effects, the substitution effect. So firms substitute other inputs for relatively expensive labor. So the demand now for the product is coming from the business. And if the wage goes up, does the business try to find machines to replace labor? Yeah, we see it at McDonald's now, right? We got the little kiosks, so we don't have to have as many people if wages go up. And then there's an output effect too. If there is an increase in the wage, that raises my cost of doing business, which means my prices of my product are going to go up, which means law of demand, I'm going to sell less beer, right? I'm going to sell less output. If I don't sell as much output, then I decrease the number of people I need to hire. So that's the output effect. You might remember from principles class, the demand for resources is a derived demand curve. The value of your labor to my company is derived from me selling the thing you make. We'll wrap it up there. See you on Monday. All right, Lawson, got you down for attendance.